Hi everyone, I hope you are doing good. So today in this video we will discuss a new DSA questions, and that is pair sum in BST, right? We have already discussed this similar type of questions in that we took we got some given array, and then in that array we have to find the pair sum, right? Or two sum you can say. So that kind of question is this. This is slightly different than that. Here instead of the vector we are getting the BST, binary search tree. And in last question also we have discussed the binary search tree, what is binary search tree, what is binary tree, right? So those if you want to watch that video, then you can go and check it out, right? So in this question, let's understand the question first. So given a binary search tree, right, and a target, right, a binary search tree will be given and a target value will be given. So check whether there is a pair of nodes in the BST with value summing up to target, right? So we have to find a pair, basically two node values, and if we add those two nodes, then the sum would be as equal to target. So that is what the question is, right? This is very simple question. Let's understand this question with example. So here the given example is this one. So here we have multiple nodes, right? Here this is the given tree, and here target is 12, correct? So now we have to find two nodes, right? If we add those two nodes, then the sum would be 12. So that is what the expectation from this question, right? So here if we sum up 4 and 8, these two nodes, then if we add these two nodes, then sum would be 12, correct? I hope you are getting it, right? If we take the another example here, the below one, this one. So here also the target is 23, right? And here this is the value, node values for the BST, right? So we represent this BST in such a way, this way, right? And if we try to add any of the two nodes, then we are not able to make the 23 as sum, right? 5 and 9, 14. This is 7, this is 11, this is 16, this is 19, this is 22. So maximum we can make up to 22, but here target is 23. So what we will do in that case, we will return false, right? So if we can make the target, then in that case we will return true. If we are unable, in that case we will return false, right? So here that is the expectation. So I hope you understood the questions. Now coming to the solution, as I have already mentioned, we have did similar questions where we used to get the vector, right? One vector, right? Sorted array basically, and in that sorted array we used to find a two sum or pair sum, right? So for example, this one is only, right? So 1, 2, 3, 4. So this is our basically array, sorted array, and in this array if we want to find like pair sum is 5, right? So 5. Now we have to find two values. If we add those two values, then sum would be 5, right? So this is the question. Just forget about this BST one. This is the normal question, right? And here what we used to do, we used to apply multiple approaches, right? And the most efficient approach was two sum pair, right? So where what we used to do, we used to take two pointers, left and right, right? From here left and from here right, right? This is left, this is right, and we used to add these two values like 1 plus 4, correct? And if it is 5, then we used to return, yeah, this is true, we found the pair, correct? So in this case we found first time only. So let's change the value here. So sum you can take is like 7, right? 7. So what will be the value? Now we are getting 5 only. So 5 is less than the target. So in that case what we used to do, we used to increment the left. If the sum is less than the target, then we used to increase the left pointer. If the sum is going beyond the target, in that case we used to decrease the right value, right pointer basically, right? So here in first case, so let me write it here. So if sum is less than target, right? Target, in that case we used to increment the left, else right minus minus, right? And what is the sum? Sum is equals to array of left plus array of right, right? And what is left? Left is 0 initially and right is n minus 1, right? So this is the code I am adding here. I'll show you the code also. So this was the approach and this was the solution we already discussed in my videos. So if you haven't watched that video, please go through my playlist and find that, and then have a quick look, right? If you know this two pointer approach, right, for pair sum or target sum, right, then this question is very easy. This is similar to that only, correct? So I hope you got this approach, right? And here first time we will go 1 plus 4, that is 5. 5 is less than this one, so what we will do, we will increment this left. We will come here, then again we will do the same thing. 2 plus 4, that is 6. 6 is also less than, we will go here, and 3 4 7 7 we found yes, true, right? So now this is now coming back to our question, main question. So here what we have binary tree instead of the vector. So what you are thinking, what I am thinking is, here we are getting the binary search tree, but we can make it a sorted array, right? And how can we make this binary search tree into like convert into a sorted array? So I have already told you where we have multiple traversal approaches, right? Multiple traversal approaches like in order, right? We have in order, right? Then pre-order, then post-order, and then level order. Level order, right? So in all approaches we traverse the tree, and I have told you that if we go through in order, right? If we go through in order, in that case we get the output in sorted manner, right? So in sorted manner, and we want that only. We want a vector which should be sorted, and once we get that vector, then we apply the same approach whatever we have discussed for 2 pointers, right? That pair sum approach, correct? So now coming back to the complete solution for this question is, so let me remove this one first. So here I have added the complete solution. So where I have added the code for 2 sum approach, right, or pair sum approach. So here you can see I have added the in order approach here, right? I am just pushing the node value into the vector, VPO vector, correct? And then I will use this vector here, here, right? I will use this vector inside the pair sum approach, this one, right? See here. This one. So I have just created vector, I passed it to the in order here, and I will fill this vector, right, through the in order here, this one, and then I will pass this vector to the each pair found, this function, and this is nothing but a pair sum problem, and where we have applied the 2 pointer approach, this one, right? So this is very basic question basically, right? We are just, this is left and right we have initialized, right? We calculated the size using the dot size, right? And we have target already here, so we just calculating the sum, and every time we are comparing with the sum with the target. If sum is less than target, we are incrementing the left. If the sum is greater than target or going beyond the target, then we are decreasing the target, right? If we found, in that case we return the true. If sum is equals to target, then this condition would be false, right? This one would be false. Sum is equals to target, this would be false, then it will go into the else condition, and here we will return the true. If nothing we found, right, if left is less than equals, right, it means we have traversed all the array, right, from here to here, right. In that case we found we did not find any pair such as that makes the sum to target. In that case we are coming out from this while loop and then we are returning false, right. And that is the expectation, that is what we are expecting from our solution, correct. So I hope you understood the complete solution. This is very basic. If you know the pair sum approach, pair sum problem and the two pointer approach, right. So for that you can refer my earlier videos. So yeah, that's all for today. See you next time. Till then, keep learning and keep exploring.